I'd like to welcome everyone to the webinar series of the Cybersecurity and Information Systems Information Analysis Center, CSIAC. Today's presentation is entitled Binary File Application Scanner, BFAS, a prototype for scanning, detecting, and reporting PII in disparate binary formats. My name is Steve Warzala. I'm the CSIAC Outreach Manager. Just a few administrative notes before we begin. First, all phones have been muted except for the presenters. Questions may be asked at any time during the presentation by utilizing the chat function. Time permitting, your questions will be answered at the end of the session. Today's briefing slides will be posted on our website within a few days. Finally, I'd like to take a moment to acknowledge and thank our sponsor, the Defense Technical Information Center, DTIC. The funding that DTIC provides enables CSIAC to conduct these webinars. It's my pleasure to introduce our presenter for today's webinar, Mr. Mike Corley. Mike is a Research and Development Associate with Quanterian Solutions Incorporated. He's involved in various advanced technology development efforts supporting DTIC, CSIAC, and the Air Force Research Laboratory in Rome, New York. Mr. Corley has 20 years of professional experience in software architecture design, software development, and systems engineering, focusing on applications of computer networking and cybersecurity. He received his master's degree in computer engineering from Syracuse University. Mike's recent research interests have been involved in exploring the utilization of next-generation cloud-enabled services. I will now turn the presentation over to Mr. Corley. Good afternoon, Mike. The floor is now yours.
Good afternoon, Steve. Thank you for that. Welcome to everybody who's joining us today. I assume this is lunch hour for everybody, and I hope that you've got lunch and a fresh cup of coffee or tea or whatever you like. I know I've got a fresh cup of coffee. And we'll dig right in, and hopefully this is, I've done my best, I think, to make it interesting to a larger swath of folks in different technical areas. I assume there's going to be some administrative folks and some software folks and some folks that aren't necessarily code oriented. So just as a forewarning, I have to say that the way that this turned out is I ended up focusing a lot on some scripting kinds of things, in particular PowerShell. So if you're not a scripter or a coder, bear with me. I'll try to be as explanatory as possible. So with that, let's dig in. So you'll have to, folks, bear with us a little bit. We're experiencing some slight delays on our end here. So if I pause for a few minutes, that's why. So just to start, I think everybody has an idea for what personally identifiable information is. But it warrants just kind of covering it. All right, I think, yeah, okay. So it warrants just kind of covering it briefly. You know, I guess we're missing a slide here, but let's go with that. So, bear with me for a moment here, folks. Here we go. Okay. So, really, you know, to start it off, personally identifiable information, it's any information that can distinguish or trace an individual's identity. And it's hazardous to individuals and organizations for a variety of reasons. I think we all have a sense for what it means to safeguard information that would disclose the identity of an individual. And also, I should say that it's more generally focused towards PII-like information in that the different organizations have different requirements to whether it be the distribution of controlled documents, you know, distribution, anything that's not cleared for public release or in general, data privacy concerns in general. So it's not necessarily just focused on things that compromise an individual's identity, but things that are relevant to an organization as well, you know, intellectual property, whatever it may be. And there is, of course, guidance. You know, there's a couple of links here that give, you know, good information and guidance on the kinds of things, the best practices for what and how you should do things. But within that, we were fortunate enough to have some interactions with some folks in the Air Force. They were looking to do solve a specific problem that related to PII, and as a result of that, we had an opportunity to really give some consideration to a couple of the hard problems that arise. So we'll get into that in more details. But our objective is really in this webinar, in this concept that we're going to talk about is we're going to talk about a number of different things, but I should say the overreaching idea that we want to come across is to develop architecturally sound methods for integrating some of the existing tools in order to get better synergy out of the existing tools. We really want to assist and enable better management of PII and some of the related problems, utilizing the existing tools out there, but in such a way that we pull them together and we get the most out of them, and in doing that without increasing or bringing about unnecessary or added complexity. Okay, so some of the major challenges that are involved in managing PII is that data volumes are large. The technologies are evolving. There are more and more options for people to communicate ideas beyond email and how that information is shared. And what you end up with is kind of a mishmash. You have information that's stored in databases. You have individual users in their desktop PCs that are generating, producing, and distributing instances of what would be PII-like. It's often the case, we identify, that a lot of organizations, for the flexibility, for the convenience, they'll have large network shares that folks connect to, and what you end up with is large volumes of information that's centrally located, but it's also replicated on the desktops where it originated from. You certainly have the situation where folks are generating emails that are unencrypted, not aware that they're sending out information that's compromising. There's so many cases in the past where I've received emails with social security numbers in them and things of that nature, because folks, up until recently, really haven't given a lot of thought to that or understood that those things are compromising. It's still a big issue today. Now, systems like SharePoint, and certainly a big thing nowadays is cloud drives. Folks are taking things down on mobile phones, and they're ending up in cloud drives, and they're ending up from there in different locations. So you end up, with all the disparate technologies, you end up collecting, often the case, lots and lots of information that's kind of scattered throughout an organization's networks and PCs and servers and so forth. And it raises some questions. What do you do if you don't know about PII that's being generated? How do you safeguard it? And then the realization that once you have a sense for what you want to look for, you find out that it's often encoded in various binary formats. It's not often the case that information is in a textual format. PDFs are prevalent. Most things are stored in PDFs. Often they're stored in Word document format, and you can get text out of that. But more often than not, how do you know if something has been zipped up and made available, or whatever it is? There's thousands of different formats, and a good number of them that are used by people in various capacities. And how do you search for information that's in those? You can't directly. So we're going to talk a little bit about how you might do that. Repositories are very large. That makes it challenging, and they're scattered throughout an organization's resources. We talked about that a little bit. So when you have copies of what you would find, if you find a document that has PII in it, how many copies of it, or how many different variations on that are located in different directories or different networks? So we'll talk a little bit about how we might go about that. And then lastly, what is it that really constitutes PII-like information? You can't enumerate all of it. We'll see that most often the case, things like regular expressions are used to enumerate all the various instances of PII, and it's there's an incompleteness aspect associated with it. You can't get it all. But so let's continue on, and we'll see how we can look at some of these. So what do you do about that? Well, there is the notion of, there's policy that when you go and you look at the guidance, there's training, and there's security best practices that you adopt, all the things that you do to minimize impact. You can go and look at some of the links at NIST and some of the others. I provided links. And it's all fine and dandy, but technically the tooling and the ability to do some of those things effectively is where some of the shortcomings is. So you can go out and purchase commercial tools. And dealing with folks, in particular our interactions with folks in the Air Force, we find out that a lot of these tools are very expensive, 6 and even 7 digits. They're so expensive. And you'd often want to do a simple function, but these tools, they often want to manage everything for you. And you can't just buy the feature, often the case, that you want to solve the problem. You have to buy, the thing that the license covers. So you get all this stuff, and really what it wants to do is manage the whole gamut for you. And in some cases, that breaks what systems are currently in place. You need to have smart people that invest in that, and just to get it to work. And then you have lots of investment beyond, technical resources, I should say, organic resources. You have lots that go into it. And it's like I mentioned, it's not often the case that it's easy to tailor it to a specific use case, a simple use case. So when you really get talking with folks, and we've talked to them a little bit, it turns out that they kind of shy away from those, and they look to solve their problems with the help of existing tools. And more often than not, they're either going to be in a Unix world or they're going to be in a Windows world, and you end up falling upon the scripting tools, scripted components, command shells, bash scripting. In the Windows world, PowerShell is the big thing for power users and for system administration tasks. And I'm going to talk about that quite a bit. It turns out there is a very useful utility, that a toolkit really, that was originally used largely in search engine appliances, and that's Apache Tika. I'm going to talk about that. We're going to actually talk about how we take several tools, multiple tools, and pull them into an architectural model and expose them to the PowerShell environment to make some of these capabilities available in a more synergistic fashion. Okay. So within option 3 that we talked about, you have tools like the bash shell, you have tools like Grep. If you're a scripter at all, tools like Grep allow you to do regular expression matching. If that doesn't mean anything to you, don't worry about it. I'm going to talk about it a little bit. But traditionally, the Unix shells, they accept textual input. Again, if you're a scripter or a programmer at all, you essentially have 3 streams. You have standard in, standard out, and standard error. So standard in is what's by default connected to the keyboard. So when you type things in, you're getting things into a program via standard in. And standard out by default is connected to the console. So that's where you see your output going to. But you can redirect those. You can pipe the output of one program to the input of another. And again, these are textual, serialized, these are text streams. In the PowerShell world, we'll see that they're not text streams, but rather they're fully qualified .NET objects. And I'm getting a little ahead of myself, so I'll hold on to that thought for just a moment. But generally, one of the biggest shortcomings of these tools is they operate on textual content, is really the thing. What do you do about things like PDF files? So, okay, bear with us here. We're waiting for this thing to switch here for us. Seems to be a little bit laggy at the moment. Yeah, come on. Okay, looks like it's doing something. Okay, so PowerShell. We talked a little bit about the Unix shells. Let me just go back here. I'm sorry, folks. This is a little bit laggy, so I don't know quite what's going on with that. Okay, so PowerShell, as I started to begin to mention, it's a task-based command shell, and it's a scripting language that's really based upon the .NET framework. And what that does is it, instead of operating on textual input and output, what's accepted and produced as input and output are these fully qualified .NET objects. And what that really does is bring a whole new set of tools and methods for how you manage Windows systems and now even Mac and Linux systems with the .NET Core. One of the nice features of the PowerShell model is it introduces the idea of commandlets. So you can build single function tools. You can expand the shell quite a bit by introducing custom commandlets to really make it, or to conform it to the kinds of things that you'd like to achieve. It's very powerful and very flexible. A lot of extensibility there. And the idea is you develop these little commandlets where you need them, and you use the richness of the existing environment to perform fairly complex tasks. You form these pipelines, and in doing that, you can get an awful lot of work done in some really flexible ways. So let's see. Okay, so here's just a typical example. So what you see in the Linux world, this was the example Linux, cat test.txt. What that's going to do is that's going to produce onto standard out. What it would do is it would print it to the screen, each line of the text of the input inside of test.txt. But what it's going to do here, that little pipe symbol is going to take that output and it's going to pipe it into the input of this grep routine, this grep call here. And what that's going to do is it's going to compare, it's going to do a regular expression match. This little regular expression here says, any digits 0 and 9, where you see 3 of them at a time, followed by a dash, followed by two digits, exactly 2 digits, followed by a dash, followed by 4 digits. So this is a pattern that would match on things like Social Security numbers. Okay, so what this would do is it would say, produce the output of this text file, pump it into the grep command, and then look for those patterns in that text file. A similar thing happens in the Windows world. Get content, what that's going to do is it's also going to look inside of the test.txt file, but in this case, it's going to produce a string. It's going to output a collection of strings, not text. And the select string commandlet, these are commandlets, what it's going to do is it's going to, so get content is going to produce this collection of strings representative of the lines of the test.txt. And this is going to accept that collection, and it's going to do the same kind of pattern matching on each of those strings. And what I've done here, I've got a few references for you. They kind of give a little insight into what Microsoft is doing to provide a little bit of management of sensitive information. I think the middle link does. And some of the others are just what folks are doing out in the field and sharing with the community what they're doing. And from what I can gather, none of the approaches take into consideration binary file formats. So next slide. Should be coming up here in a minute. There we go. So some of the shortcomings of the typical tools. The regular expression based. So the idea here is what you do is you provide a pattern. So in this case, if we wanted to look for Social Security numbers in text, what we'd say is anything that begins, this little hat says anything that begins with a sequence of 3 digits followed by a dash, followed by a sequence of 2 digits, followed by a dash, and ending with 4 digits. Okay, that's really what it says. And you end up matching those things that fit that pattern, but you need to have an instance of a regular expression that matches all these variations. So unless I'm very crafty in how I develop that regular expression, things like the one you see here, the 001122 with spaces, that's not going to match. So they are pattern-based, and you need to have a variation for all the different instances, and there is no semantics or context that's associated with that. If you wanted to keep track of specific entities or keywords, you need to maintain those side saddle, and then you can do a comparative kind of thing to build context. But in general, the tools don't provide any help with context or those kinds of things. And it tends to be fairly complicated to get some of that information. It's generally hard to maintain. You need to be thoughtful about how you do that in order to get some of that information available to you. So there is an inherent incompleteness problem. You can't enumerate all the things that are qualifiable as PII, but certainly you can get a lot of them. And this is, when you talk with folks, this is really the sort of thing that they're doing out there. So they are defined for textual content, but we're going to show how we can use Apache Tika to extend that to binary formats. And you do need to be algorithmically aware. These are big, often gigabyte or terabyte size repositories, and when you say go on your script, don't be surprised if this thing runs for days or weeks or even months. So it can be a big deal. So how do we make progress? Well, in our case, there are a lot of different good approaches out there. If you look around, you see how folks are approaching it. Our focus isn't to solve a specific problem, but rather to look at architectural ideas for how do we combine and integrate well-known tools or existing tools. How do we bring them to the table so they can play? And the goal is to achieve or maximize the overall effectiveness of the union of all these tools. We want to get the synergy of all these tools and their capabilities, but we want to do it in such a way that we don't bring in feature bloat or add complexity for the user. That's just not helpful when you have to go through a lot of rigmarole to use different tools. So a little bit of thought in how we do that. And what we're going to do in this particular webinar is we're going to look at PowerShell, we're going to look at Apache Tika, and we're going to look a little bit about how we would use some machine learning ideas at the end. So, and we'll notice there are different technologies. PowerShell is inherently .NET framework based. Apache Tika and OpenNLP is the natural language processing toolkit that we use as the machine learning example. Those are both Java based, and we're going to look to pull those in a reasonable way and show how they can be made to interoperate. So that's really the idea. Architectural soundness, and the game is partitioning complexity. You want to solve the problem where the problem's intended to be solved. That's really what it is. You can't get rid of complexity because you end up changing the problem. But what you want to do is partition it so it's manageable. And we do that through good software design methodologies. At least that's the goal. Okay. Next slide. Okay, so as an example, here's a PDF. I hope everybody can see that. I should say that for this series of the slides coming up, if you have your resolution set to 1080p, then it shouldn't be too hard to see. That's what I'm using. But what you see here, if you're in the DoD at all, this is an example of a DD2875. This is a form that you fill out that is for gaining access to any IT system. And what was traditionally the case is you put your social security number on this thing, and that's part of the processing that's used by the administrative folks to get you access. And you cover this thing with a privacy letter and you hand it to somebody. But now these things are stored all over the place. This is just one example. What do you do with something like this? Because when you look at it, it looks something like this. Wait for the next slide to pop up here. I think I have, well, I'm going to show you an example of it. There it is. Okay, I don't know quite what's going on with our system. It's so slow right now. But so if I just print that out, these are printouts, one in Linux, one in Windows. They give you a sense for what these file formats look like. They're not text. They're a binary file format. You can't look for things in them. So if you're not a technical user, it's easy to glaze over that and not to realize that. So I want to talk a minute about Apache Tika and what it is. It's something that everybody should know about, I think, because it's a very, very useful toolkit and framework, and it's used in many places. What it really does is it's a toolkit, a Java-based toolkit, and it detects and extracts metadata and text from over 1,000 different file formats. Okay, and that includes, image file formats. It includes video, audio. It's quite a useful tool. Okay, it's traditionally used in search engine, particularly the data transformation. When you ingest something into a search engine, you need to make it available to index it, and it's used in that ingestion pipeline. I'm going to show you an example of that a little bit. But it's also used for content analysis. It's used for translation. It's used for a number of different things. So, and how it works is there's two, and I provided links, so you can go and look at the specific details of Tika for yourself. I won't get into describing too much of the detail, but two foundational ideas. It does content detection, and what it does is it provides a number of methods that it applies on looking at the information to determine what type it is. Lots of header analysis, there's some heuristics involved, there's something called My Magic detection, there's resource aware, so if the information is available as the file extension is used in some of the determination, but it's quite good at doing that. And the way it does it is by managing all of the different detection mechanisms under a facade interface. So the facade is a design pattern, a software design pattern, and what it allows you to do is to make a single call to a function, detect is the example shown here, and that'll delegate the calls off to the specific underlying components, hiding much of that complexity from you and just giving you back an answer. So in this case, what it would do is return a media type object that it describes its best guess as to what type of file it is. And that's utilized alongside with the parser interface. So again, a facade design pattern. And what it does is it makes use of all of these existing file format parsers. There's a large community of folks that are maintaining different parsers and contributing parsers. And it's a continually growing community of folks that are maintaining this. But as an example, PDF Box is a PDF parser. Something called Apache POI is all about handling in sundry Microsoft documents. And there's over 1,000 of them. And essentially, all of these different parsers are made available through a parse interface, a single parse interface. And all those details are nicely partitioned or hidden away, abstracted away from you. And you don't have to worry about that underlying complexity. And they're very, very flexible and customizable. You can plug your own in. Tika has evolved to be something that's very versatile. I think coming up here, let's see, wait for the next slide. Here's an example. This is relevant. This is where it kind of originated. You have a search engine appliance, something like Apache Solr or Elasticsearch. And the way that it works is you ingest things into the engine and you query the engine. So if you look at this top left here, a document would go through these in sundry processors. So you might remove special characters, things that you need to remove in order to properly tokenize. So then you tokenize. Then you remove stop words, things like the ands, its, thus, and this is all optimized toward indexing. You know, term frequency, inverse document frequency. The idea here in this case is to rank documents. So that's what this is being optimized for. Stemming, so you're going to, you know, remove the INGs and you're going to get the base word. And then you can plug other components in. Suppose you want to do some kind of categorization or something of that nature. So machine learning that would use a model to determine how to tag the information or how to categorize it. You could plug those in here. So what you need to have is, before you can do any of that, is the text. All of these operate on text. And that's where Tika would come in. So right in between the little green box that says doc and character filtering is where you have this pre-processing step where Tika is involved in this ingestion. So it's often running in these architectures, and folks don't even know it in many cases. So on the other side, just for completeness, you have a query that comes in, and the same kinds of textual processing is done in a staged processing way on the query, and that's matched against the Lucene index, and what you end up getting back is these ranked results. And you know, if you do any searching in Google, you see your ranked results. It's this kind of a process that's going on, albeit much more complicated in the Google world, but foundationally this kind of idea. So I wanted to point it out because it's where Tika is you know, used traditionally very much and is still today. This slide coming up as soon as it loads for us. Okay, as soon as it loads for us. Sorry, folks. Bear with us here. Okay, let's try that again. Okay. Should be just any second here. Or not. Wow, that's slow. Okay, so this slide here gives you just a little bit of information. You can look at this offline. I'm going to start running short on time unless I pick it up. But this gives you some idea of some of the capabilities in Tika and what it can do. Lots of machine learning support built right into it. And also OCRing, things of that nature, optical character recognition on, you know, image files and whatnot. Lots of neat stuff in here. So I invite you to visit that later on. Okay, so this is an example. I wanted to provide one example of a shell script, because this kind of motivates kind of where we're headed. So this is what folks might do, and this is a simpler instance of what folks might do to detect PII. So what I've got here is a little array that has in it a few keywords: my last name, a regular expression, password that'll match on capital P, lowercase p, a keyword, SSN, and then a little regular expression off here to the right that matches on social security numbers. And what I'm doing in a little for loop, I'm iterating over those, and I'm going to do a extraction. So I'm going to say, for each of those files in my list, the first thing I'm going to do is call Apache Tika on that. And you see that going on right here. I have this Java jar, Tika app 17. So what I'm going to do is, this is all in Linux now, mind you, I'm going to get back the textual content, and I'm going to pipe that in to Grep. And that's what's going on here. The output of that's being piped into Grep as input. And for each of those expressions, Grep is going to do a comparative match. And you see the output, what it's doing here. It's showing me instances, like down here at the bottom, it's highlighted that it found a social security number. So I know this looks simple, and perhaps kind of silly, but when you talk with folks, it's expansion of these kinds of ideas that folks are currently utilizing. The difference being is they generally don't think to put in place the Tika piece. This is the part that would allow you to do the text extraction. This is actually performing the operation on that PDF file that we looked at earlier on. So in order to get that out of there, you need to turn it into text, and then you can do these kinds of things. So this will get more interesting in just a few minutes, I promise you. So that's the Linux side. Let's take a quick look at the PowerShell side, and then we'll kind of pick up the pace a little bit here. I'm waiting for the slide to advance. Okay, so here's a similar thing. Okay, in this case now, we're going to up the capability a little bit. We have this thing called import Tika command. What I've done here is I've imported a custom commandlet. Remember, a commandlet is a little command that you can build into a shell. If you build your own, you can pull them in and use them as if they're extensions of the existing PowerShell commandlets. So you see me doing a similar thing. I've got a little array, the same list, and then I iterate over it. And what I'm doing here is I'm saying get child item. So I'm saying inside of PII test files, give me all of the lines of that text file. And it turns out what that is, it's just a listing of files in a directory. And because it's a .NET object, what I'm going to do is I'm going to pull off its full name property. So what that's going to give me is it's going to give me a list of file names like this here, like C:\\m desktop PII test files. That's what that provides me with, just by doing that little for loop operation there. So now what I'm going to do is I'm going to take that file name and I'm going to call getText on it. GetText is my custom commandlet. I'm going to show you that in a little bit. And what it expects is a single string argument file. So the textual content will be stored here in text content. And then what I do is I take that for each match. This is a list of this text content is a list of matches or a collection of strings. And I just iterate over those and I do a comparative thing. And I get back the locations in this PDF that illustrate where I have, as an example, social security numbers. You can see right down toward the bottom. And matching things like the SSN keyword. You see those instances. I'm looking for my last name. You see an instance of that in there. So moving right along, this is what it looks like. I'm going to show you the code for this in a few minutes, but once you've imported your custom commandlet, it's available along with the rest of the existing PowerShell environment, all of the commandlets and the ecosystem that comes with it. You can see this takes a switch parameter, so I can say, if I wanted to, I could specify JSON. What that would do is produce a JSON output. Notice my file name here. The file name takes a list of strings, not objects in the sense that, or textual stream objects in the sense that the Unix shells work, but fully qualified .NET objects here in this case. So it's usually a stumbling block that folks have to go through before they begin to use PowerShell effectively. They expect it to operate like Unix shells, and it doesn't. It's object-based. So let's go to the next slide. Okay, so here's an example. What you see me doing here is providing, remember, the getText commandlet will take a collection of strings, an array of strings. So in this case, you see me I'm providing one string as input to it. And instead of getting back all of the binary content, you see it nicely producing for me lines of information, okay? Now, I made some real simple assumptions in this first version. There's a couple of different versions of getText. I'm going to show you how they work and how you would build one, okay? But what I'm doing here is I'm just basically saying I'm counting on each line. Every time I hit 80 characters, I'm going to dump out a line. So that's what this is producing. It's taking as input a collection of strings, and it's producing as output a collection of strings that are 80 characters wide. And whether or not you do that, you probably wouldn't do that. But for the case of example, I wanted to demonstrate that you have control over how these things work. Here's another example where I'm providing it with an entire list. So what this would do is this would produce the textual output for all of these files. And I would get those back as a collection of strings, and I could kind of do whatever I wanted to do with them. I could pipe them into another commandlet. But what you'll notice here, backup.pst, this is the format that Outlook uses to manage email content. So this will also keep track of things like attachments. If there's attachments in there, they're encoded in there, and you can pull those out. You can match on those. A PDF file and then a PNG file. You can absolutely do text extraction on image file formats because it uses OCR parsing capabilities. It's using Tesseract under the hood. So you can do those kinds of things. So just kind of getting set up here for some more interesting things here. So here's an example. I don't think you can see this, but perhaps you can. There's another instance of it coming later on. This is what this is how you declare, how you build a custom commandlet. Generally, you don't have to build them in C#, but generally speaking, this is the C# programming language that you see here. Looks a lot like Java, but foundationally, what you need to do is you need to write a class. If you're not a programmer, bear with me. You write a class. That class has to inherit from commandlet-based class or another one called PS commandlet. But once you've done that, you now have the infrastructure that you've inherited to basically build a custom commandlet. There are a couple of interfaces you have to provide or functions you have to provide overrides for. You have to decorate them with these attributes, this commandlet attribute. So the idea is with a commandlet is you're going to operate, you're going to perform some function on a resource. And in this sense, the resource is text, and what we're going to perform, the verb, is a get. So we're going to get text. And that's what this commandlet's called, because that's the operation. We're going to get textual content from a file that we pass in. So down below, it's kind of hard to see. There's a method called process record. So after you've supplied input on the command line, this process record is going to get called, and basically you can see that there's this parameter here called file name, and it handles. Look what it returns. It returns an array of strings. I know this is hard to see. I'm going to have another one coming up later on, but the idea is it's going to accept this array of strings, and then you can enumerate, you can iterate over them. If you look back in process record, for each name and file names, you're going to call Tika app. And what I'm doing here is I'm calling the Tika code to extract the content for me. That's what you see up here in the Tika app method just along the top. I'm going to get the result back, and I'm going to perform various operations on it. I'm going to remove new lines. I'm going to remove carriage returns or tabs. And then what I'm doing is I'm just going to iterate over it. Like I said earlier, every time I reach 80 characters, I'm going to write a string object out onto the console. So that's going to get written into the pipeline, so it can be piped into another commandlet rather. So that's what's going on here. And I'm trying to be quick about it because I'm going to have some more interesting examples later on. But you can come back. These are going to be provided online. You can look at some of these, and I've got good links here that you can go and take a look at and see how you would build a commandlet. So just wanted to point out, I'll do it briefly, the way that I'm making .NET interact with Java is through something called IKVM, and it's something that was originally what it is it's a number of different things. It's a Java virtual machine implementation for .NET, but it also allows you to do cross-compilation. So you can take a jar file or something that was built for Java in bytecode format, and you can cross-compile it into Microsoft's virtual machine speak, which is called CIL, Common Intermediate Language. And then you can consume and use those libraries directly. Now, this was dropped originally, and there wasn't support for it, but this organization, Windward Studios, has picked it up, and they are maintaining it. And it's quite an interesting way to use Java code in a .NET environment, and so on and so forth. So I wanted to point that out. So moving right along. Okay, so here's some more interesting examples of how we might do things. And I've been kind of building up to get here. So here's kind of what's going on. This get child item is a commandlet, the top screen, the top blue box you see here. I'm basically calling it on a folder called test files. And what you see is its output. It's outputting this. There's nothing I'm piping it into. So its output is a serialization to the console. And you see, because this is a .NET object, okay, but go to the next blue box. I'm doing the same thing, get child item test files. But in this case, I'm piping it into select object. Because it's a fully qualified object, I can expand its properties. So what I'm saying is, give me all of the files, the child items, the files in this folder called test files, pipe that into select object, and give me the full name property. So I get, as you see here, a listing of all my files. Now, in the third box, I go one step further. So I get child items, pipe it into select object, expand its full name, and now I iterate over them. So for each of those objects, each of those files in that directory, I'm going to say, give me the text. And all I'm going to say is dash file name and the current file. That's really what's going on. So this for each object is a little commandlet that just knows how to iterate over the collection. It accepts a collection of strings, okay, from the select object component, this list that would be in the directory, and it's going to basically give me the text for those. So what you see is the first few lines out of the first file, and then I go one step further in the very bottom here. This is demonstrating how you use these commandlets, and you can pipe them together in a pipeline format in order to get some pretty complex operations. So I'm saying here in this bottom blue window, give me all your files in this directory, and then pipe that into select output to get the full name for each of those, pipe that collection into the for each object, iterate over all of those, get the text for them for each one at a time, and then pipe the text into select string. And what I'm doing here is I'm looking for what amounts to a social security as a regular number, as a regular expression in all of those files for whatever I would pass in. And you see some of that information coming back on the console here. So that kind of gives you a real quick crash course of how PowerShell works, because we're going to demonstrate later on here in a few minutes how we can pull some of these things together, different technologies into PowerShell and be able to take advantage of their capabilities. That's kind of what we're building toward. So before we do that, I wanted to point out, the title of this webinar is something called BFAS, okay, the Binary File Scanner Application. Some of the folks that we were working with that we provided these for, they said it'd be nice if we had a GUI interface. So what we did is we quickly thought about some of the problem space, and we packaged these things up as a collection of .NET abstractions. So there's a file cache, there's a report manager, there's these various pieces that produce for us. Basically, we'll wait for the next slide to pop up here. One more. That's just an architecture diagram. Let's see. Okay, just wait for that to come up here. Okay. So we're doing okay, and things have slowed down again. So we're just going to be patient and wait for it. Be momentary. Sorry, folks. Yeah. I don't know. Well, let's try to go back. I'm sorry,
I was just saying I'm actually seeing the slides. I think they're. I don't know how it's faring for everybody else, but it appears I'm seeing the slides on my computer before they're popping up on yours. So I just wanted to give you a heads up on that. So yeah, we got at least one other individual saying that's kind of the same.
Yeah, I see that. For me, there's a significant delay. I have to wait for it. Yeah, I think John was also seeing that. But in any case, there's a slide that popped up here. So let's go with it and hope that it works out well. So what we did is we provided a GUI. And this GUI will allow us to basically turn it loose on a file share. That's what you see over here on the left. You basically point it at a set of files or at a directory on a file share, and it will iterate through that entire collection, traverse the directory structure. You can specify regular expressions and some various other options that you can provide here as input. I don't have time to go into all of them, but what it attempts to do is package up all the features and capabilities, and it'll allow you to do some parallel processing, you specify the number of worker threads, and what that'll do is it'll generate an XML report format, which I'm going to show you. And this screen over here on the right is a way to iterate over that. It's a machine readable report that allows you to iterate over the content of it. And in this case, it's a simple idea of a visualization. So for each of the expressions, you can see all the files that match, and you can click on those, and you can see all the cases where there was a specific match. Just a starter prototype for how you might visualize some of this, but okay. The file caching component does some interesting things in there. What it really does is it looks to keep track of it. It's a hashing technique that's used when the file is processed, so that later on, as files are visited, it's going to do comparative analysis, and it's going to be able to say, hey, we've already seen this file in a different location. This is a duplicate file with a different name. So basically, if you want to map out where some of these things are identified on your network or in different systems, okay, then this provides a means by which you can add a little bit of information and you can start to determine where some of these things exist. So that was part of the thing. How do I know where things exist? Well, as you start to find some of these instances, because there's a hashing function going on here, you can add a little bit of information to that and keep track of where some of those things might exist in a larger set of systems. And we're going to look to extend that to use something like a NoSQL DB. This is all very preliminary ideas, proof of concept ideas into this. If we move along here, so I am waiting for the next slide to pop up. Here's the machine readable format. So this is basically a collection of PII. So the idea is you've got a number of records. A PII record contains a pattern. It contains a number of files that matched. And for each file, it contains a match segment. And each match segment says, we want to give you the information where it matched. So in this case, this first top row, you see, or this first section here, I should say, you see 020. This is a social security number, okay? And it gives you the starting and ending index, and it gives you the before and after context. So the idea is you can specify, I want to know what happened around the match. I want to have a little bit of context because the match alone doesn't help. So it does that for each of the files and each of the expressions. You have this machine readable format that can be used for secondary processing. And that's really what we saw in the previous slide when we were visualizing it. We also said, this is interesting, let's build an Outlook plugin that uses these capabilities. So we did that, and this is just a concept of it. So let me move on to the next slide. And I'm waiting for that slide to populate. Okay, so here's an example. What you see over here to the right, there's a single regular expression that was put in, social security numbers. And what I do here is I just generate an email to myself, and I go to send it out. And what it says, it does a little bit of analysis on the text in this case, and it says, hey, you've got one occurrence of PII. What do you want to do? And there's a little logger function that sits over here on the right. You can see it. And the idea is maybe this logger is something that's sending information to a central location or to an administrative person or to another processor where it can be interpreted in a more meaningful way. In this case, it's just a proof of concept. You see it popping out in the plugin, but there's lots of potential for what we could do with this. Another example is that PDF, that DD2875 PDF. What I do is I attach that, and upon attaching it, what it does is it scans it for me. It does the text extraction thing like you saw in PowerShell. It scans it, and it says, hey, we've discovered one instance of it. And over on the right-hand side, you can use the little scroller bar, and you can see kind of the line number and where it matched. Those kinds of things are available to you. So that's the Outlook plugin. And then lastly, what about machine learning? Okay, so these are really algorithms for processing text. So we're really talking about text extraction here. So what was natural for us was to look at natural language processing toolkits. The one that I picked was OpenNLP. I was a little bit familiar with it. It's a Java technology. And then the other that's very well known is NLTK. And specifically what we're going to demonstrate in this example is the named entity recognition, the NER components. And the idea there is to find and extract instances of named entities. There's pre-built models that are available for identifying people, places, organizations, those kinds of things. And there's lots of other capabilities for doing sentence segmentation, sentiment analysis, parts of speech tagging, all the semantic kinds of things that are of interest. You can do those as well. No time to demonstrate how those work. But definitely the named entity extraction piece was interesting, and that's what we're going to show here in a couple of minutes. So we tested that with the pre-trained models. Training a model for your domain is something that's really where the work is, in the data handling, the data cleaning, and the transformation and the training of the model. Lots of data is needed to do that, but you can do it, and there's guidance for how to do it. But once you've done that, you can do a pretty reasonable job. But the pre-trained models are interesting. They do a pretty good job right out of the box, and that's partly why we picked this, because we can play with those directly. Now, I should say one of the problems that's difficult is the named entity recognition. It likes to operate on something that amounts to a sentence. These are probabilistic statistical models that are looking for things like the placement of words, the use of capitalization, the frequency of occurrence. Those kinds of things make up the model. And things like a period, which denote the end of the sentence, they're pretty ambiguous. They're used in lots of different places. So it turns out that in disparate bodies of information, PDF files that you turn into text and other things that you turn into text, okay? It turns out that the data cleaning part is where some of the hard parts are. And it's interesting to look at. We've done a little bit of it here. So I'm going to hope in the next few minutes as we round up to show you some of that, but you can come back and look at it for yourself too later on when these are posted. So I'm waiting. There we go. So we're going to show you some basic examples. And in doing that, we're going to develop another commandlet, a commandlet that pulls OpenNLP into the pipeline. So I'm going to skip to the next slide and just get to it here. Okay, so here's an example. So named entities DLL, that's the implementation of the commandlet. And what you see me doing here is taking this literal string. Now keep in mind, in PowerShell, everything is a .NET object. So this is really a string, okay? And I'm going to take this string and I'm going to pipe it as input to get entities. And I'm going to have a model parameter here. And it says, give me the model for persons. So I'm going to do an extraction of names. And you see it works nicely. These are nice, clean little examples, and you expect them to work nicely. And they do. So it pulls out my name and it pulls out my colleague's name. I do the exact same thing in the line below it, but I'm passing it the organizational model, pre-trained model. And you see it nicely pulls out the organizations, Cybersecurity Information Analysis Center and Air Force Research Lab, as you'd expect it to. So moving right along, I'm waiting for the slide to come up now. I don't know if anybody else is seeing it, but I'm not. So wait for that to come up. Sorry about that, folks. I really don't know what the delay is.
It just popped up on my screen, Mike.
Ah, okay, so for me too. So here's a real example. What I've done is I've taken, I should say a more real example. I've taken the abstract for this webinar, okay? It's a PDF file. You can see it here. You can read it. This is what it looks like. When I go to the next slide here, I'm waiting for the next slide to pop up. Let me know if it pops up for you, Steve. Okay,
there it is.
So that's what it looks like. Yeah, if you were to, so what I'm doing here, there's a little get content commandlet, okay, and I'm just saying, show me the textual content of this file, and I'm passing it. This is what it looks like. So you can't search it, but let's take another look at the next slide, and let's use our I'm waiting for it to pop up. Should be just a minute.
Yeah, we've got it up, Mike, on ours.
Yeah,
we can see it.
Yeah, I don't have it yet, so unfortunately,
okay,
folks, I can't see it. So I'm waiting. I don't know. I apologize. Okay, we ended up somewhere where we didn't want to be. As I'm clicking along here is what I'm doing. Okay, so here we go. So what I'm doing here is instead of calling get content on, I'm calling get text on it, and I'm passing it the file name. And now what you see, this is another iteration of the get text commandlet. What I'm doing here is I'm doing my best job of trying to detect sentences. I'm looking for situations where a period occurs, and immediately following that is a space. And if I can't detect that, then I'm just going to go ahead and pick new lines. So this is supposed to be a simple example, but you can see it does pretty well. This is a case where this one's already pretty clean. That webinar abstract is already using good sentence structure. So for the most part, there's not a problem in this case. So you can see though that that works. So what I'm doing here is I'm taking that input now, okay, that test file webinar abstract input, and I'm piping that into the get entities commandlet, and I'm utilizing the organizational, the organization pre-trained model. And you see it pulling out a variety of things. It's not perfect, but it pulls out CSIAC, it pulls out BFAS, it pulls out our company name, Quantarian Solutions, you can see that. It pulls out Air Force Research Laboratory. So pretty good right out of the box. And you can think about how you might build your own models that represent the entities that are corresponding to your domain and do these kinds of things in a more realistic form. So if I go to the next example, so here I'm doing the exact same thing, except I'm looking for names. I'm using the person, the pre-trained person model. And I'm the only person in that abstract. So what you see it pulling out here is my name, and it does what it's supposed to do. See, so the point is, what you see here is the use of building commandlets to pull in different technologies. I'm pulling in Apache Tika, pulling in OpenNLP, and other technologies if you want to, and using them in a in a consistent environment. And what you see here toward the bottom is just to kind of give you a sense. Once you import them, this get text, you can see it takes an array of strings or a collection of strings, okay? And the get entities takes a model, okay, a single string, and a file name as a single string, and that's exactly how you see them used. So the point is, around environments and as powerful as PowerShell, the opportunity there to apply some interesting software techniques to pull them in and expose them within a common environment, a common paradigm, so that you can increase or maximize the synergy. You can think about cases with the commandlets where you can be very specific about the options that you provide to do data cleaning for a specific application, or if there's side information you need to maintain, information that helps to qualify entities, you can maintain that and provide those as input to a get entities custom commandlet, or whatever it may be. Maybe it's sentiment analysis or something else that you're doing. The objective in this webinar was to kind of get you thinking or share some ideas for how a different look at this might be possible. So I think that's about all I have. Let me go to the next slide here. These are just a few more examples. I think what I have later on, I'm going to let you guys look at them because we're out of time. The code snippets are available. So I show you how I build the commandlets. This is the Tika commandlet. I won't go through it with you. There's not time. The next one is the Java code coming up. This is the implementation of the get entities code, okay, in Java. And now what I'm going to do is I'm going to write a commandlet that's going to make use of this code. And that's what's coming up here. And there it is. So you see, in this case, I'm just having some fun. And the commandlet is going to spawn a process which is going to provide a command line input to the jar file and wrap its outputs and make that available like you saw it in the PowerShell environment. So interesting and neat ways you can do things. You wouldn't necessarily want to do it like this, but you could. And that's really the objective. So hopefully what you got out of it is architectural ways to pull different tools into a common paradigm so that you can flexibly make use of their functions and their capabilities in a more synergistic way. And that's it, folks. I apologize for the technical difficulties we had, and hope that was helpful to as many folks that are listening.
Hey, thanks, Mike. Yeah, thank you. So let me. So if any of the attendees have any questions for Mike, you can hit us up in the chat function. Send us a message, and there's a lot of there's a lot of good information in there, and it may take folks some time to digest that. So even if you don't have questions right now, if once we get this posted up on the website, if you want to take a look at it, dig in deeper, and if you have questions for Mike on this, you can definitely we have our tech forums on our CSIAC.org website. There's a couple different forums on there, the cybersecurity, the software engineering. If you want to send us a message afterwards, we'll definitely take a look at your questions, and we'll have Mike get an answer back to you. So let's see, we do have one question, at least one question, Mike. Did you mention if this approach works on PowerShell for Linux plus Mono?
So that's a really good question. That is something that I have not tested. I think it will. The PowerShell core is what you want to look into for Linux. The .NET Core is something that there is a PowerShell core. I didn't have time to experiment with it, but a large amount of what you see here should be functional in the Linux environment because of core. Perhaps not all of it. PowerShell core is still up and coming. It doesn't have all of the completeness that the traditional PowerShell 6 has. So, but that's something that's definitely worth looking into. Yeah.
Thanks, Mike. Yeah, we just had a question on where the slides were going to be posted. So yeah, they're at our website, and if you look under resources, there was webinars or podcasts, that'll get you to the recording of the webinar, and the slides will also a PDF of the slides will also be there as well. So
Mm-hmm.
And,
thanks very much.
Yeah, I don't think we have any other questions right now. So I just want to reiterate, Mike. So this was basically a proof of concept demonstration, and the initial application was looking for PII, but it's broader than that, correct? It's not. That's just the particular application you were working on to start.
That's correct.
So it can be. It can be any kind of information that an individual or organization is interested in searching for. Your BFAS tool can be customized to to search for and find that particular information of interest.
That's correct. Yeah. Okay. That was hopefully what we tried to kind of get across in the last part of it there.
Yep. Yeah. No. And I just wanted to kind of foot stomp that and emphasize that that.
That's a good point, Steve. That is really the goal. You start off with that, but yeah, it's PII like information. Anything that is, it might be distribution statements of documents. It might be anything that would amount to a data privacy type application. So many different applications. It might be sentiment analysis. You might be doing opinion mining or something. But anything that is geared to operate on text and be able to process and discover information in text is really what the application is, So.
Okay, and I just want to read it. We got another question, and the question is, the individual says that he missed part of the presentation and is wondering if he can ask questions later. And definitely, yes, you can send us questions. Like I said, we have tech forums on our site. Or you can send a question to info@csiac.org, whatever is easier for you. But yeah, come to the site. If you look over Mike's info and you have questions on it, shoot us a message, and we'll take a look at it and get you some feedback. And we'll also, if we do get questions, we'll post them on our forum so that everybody has access to the reply, so everybody can see the answers to the various questions that we might receive. So with that, I just want to I want to thank Mike for taking the time and sharing his expertise with us. He's doing some interesting work. He's taking advantage of the tools out there, but kind of extending the capability. And so one of the things we like to do here at CSIAC is provide lessons learned and best practices, and that's kind of what we were hoping to do with this presentation. Getting this new capability, making folks aware of its existence, and so thank you, Mike. And
thank you, Steve. Thanks for everybody.
I want to thank everybody for attending, and we'll hope to see you at our future webinars. Thanks, and have a good day, all. Goodbye now.